morning. I hope everybody had a nice weekend. So if you would go put all your electronic devices away. Okay. So after I finished grading all of the quizzes last week, some people did pretty well, no complaints at all. But overall, some people didn't, and it's a majority who didn't do very well on this. And then when I went back and looked at my notes, realized that that was more than likely my fault. So I'm going to reteach it, and then we're going to retest it. If you got a really good grade on the first one, I am going to add some problems to it, just so you know, because there's some things I left off that I probably do need to go ahead and cover for the next unit. So you can't do any worse on the second quiz than you did on the first. So if you got a 14 out of 16 on the first one, and you get a 10 out of 16 on the second one, I'm going to let you keep that 14. But I'm going to do grade replacement for anything that's an improvement, right? Because they just overall weren't as good as what I thought they should be. So what I've passed out to you is the notes that I'm going to use today. I've got the definitions, and then I'm going to go through and give you examples, and then we're going to practice a few problems together, and then I've got 11 problems for homework, but I've got that printed off for the people in class. So for you guys, I've got your homework here. So that's going to be my plan. So this is 5-1, operations with polynomials. But more importantly, I wanted to be the properties of exponents, because I took it for granted that you guys remembered the properties of exponents. And that's not necessarily the case. So I want to go over what those are first. So the first thing I want to go over is what's called the product of powers. And that's when you're multiplying powers with the same base. Okay. Now, just for a review on that, this is considered a power. This whole thing is considered a power. Okay. The bigger term here is the base. Okay. That exponent is attached to that base. Okay. There could be a coefficient out here, but that exponent is only attached to that base. Okay. When you are multiplying powers with the same base, all you do is add the exponents. You don't change the base, nothing. So if I took m to the third times m to the fourth, when I add those, I'm going to get m to the seventh. Okay, not 2m to the seventh, just m to the seventh. And if I did 5 to the third times 5 to the seventh, just making that number up, then again, you don't multiply these two, don't change the base, you just end up with 5 to the 10th. So if I give you this problem, 2x to the third times negative 4x to the fifth, you multiply your coefficients. So 2 times negative 4 is negative 8. And then you add the exponents, so that becomes x to the 8th. So any questions on the power to power, or on the product of powers? Most everybody did okay on that one. Okay, that's not really where we struggled. I think everybody's kind of got a handle on that. Quotient of powers is when you're dividing powers with the same base. Okay, this is where it got a little sketchy. So if I do something simply, x to the fifth divided by x to the third, I just subtract these exponents. So this becomes x 5 minus 3, which equals x squared. Just equals x squared. Now the problem that we ran into on the test was this one, and I don't remember the exact numbers. I think it was 4 and negative 3. Is I gave you something that looked like this. A lot of people put 1, because 4 minus 3 is 1. But that's not what this problem is, because this is the same as this, 4 minus negative 3. 4 minus negative 3, which made that x to the 7th. A lot of people miss that one. And if you have this type of problem, you're going to go ahead and divide these coefficients or simplify the fraction, okay? And then you subtract the exponents. So I'm going to end up with 1/2, so 1 over 2. 5 minus 2 is x to the third. But x to the first divided by x to the first, well, 1 minus 1 is 0. These cancel out. So there should not be an x in our answer. And some people kind of miss that one too. I think it was problem number 6 or 5. Okay. And that's how you divide powers with the same base. Can I answer any questions about that from anybody in the class or anybody online? No? Okay. All right, well, a power to a power is when you have a power, like my x to the third up here, because we established that that was a power, and I raise it to another power. So I took x to the third power to the second power. When you have a power to a power, you multiply these exponents. So this is going to become x to the sixth. This also works for division. If you have a division problem that's raised to a power, do it this way, and I'm going to raise this to the third power. That 3 on the outside goes to everything on the inside as an exponent. Okay, so this is going to be x to the sixth, y to the third, and then 3 to the third. Then you would simplify that 3 to the third. Now, one of the most commonly missed problems on the test was the first one. 3 to the third is not 9. It's 27. And a lot of people, I don't know if we were just rushing to get it done, but a lot of people put 27. Okay, these are powers. So the exponent on the outside goes to everything on the inside, and you multiply those exponents because it's a power to a power. If I give you this one, x to the third, y to the negative fourth, z squared, and I take this whole thing to the third power, okay, then this becomes x to the ninth, y to the negative 12th, z to the sixth. And I'll deal with this negative 12 in just a second. Well, I guess I'll deal with it now because I'm ready to talk about negative exponents. So taking this answer from this example and putting it here, negative exponents, it's not that you've done the work incorrectly, it's that the problem's not simplified. Okay, this isn't simplified. So some of you, I wrote notes on the quiz, and I can pass those back if I haven't already, that said no negative exponents. Well, what I mean by that is if I put this in fraction form, and fraction form, when there's no denominator, just means I put it all over 1. So I'm going to take the variable with the negative exponent, and it's which number are you looking for? Negative 12, y to the negative 12. I'm going to take the variable with the negative exponent, and only the variable with the negative exponent, and I'm going to move it to the denominator, move it here. So that's going to become x to the ninth, z to the sixth over y to the 12th. Now it's simplified. If your negative exponent is in your numerator, like that, x to the negative 8, then you're going to move it to your denominator. If your negative exponent is in your denominator, that's m to the negative third, then you're going to move it to your numerator. And you only move the negative exponents. We had a problem, and I think it was number 3 on the test, or even number 3 and 4, you got an answer that looked like this. I'm just making this up because, again, I don't remember these totally off the top of my head, but I know it was a -5, and there might have been a c to the 3, d to the -4th was the answer. Okay, the only thing that moves here is this. Some people move this. You don't move negative coefficients, you only move negative exponents. So the answer here would be -5c to the 3rd over d to the 4th. Okay, again, it's not that you did the work wrong, it's just not simplified. And hopefully, if there was some confusion on this, I'm clearing it up. And now, let's talk about the zero exponent. It's something that we kind of forgot with one of the problems. Probably problem number 1, I think it was 27 to the 0 power. Anything to the 0 power is 1. Anything. X to the 0 power equals 1. 3 to the 0 power equals 1. X squared, y to the 3rd, the whole thing raised to the 0 power, this whole thing becomes 1. Not 1x, not 1y, just 1. Okay? Now, simplifying polynomials. When we go to simplify a polynomial, and I'm going to do a couple of examples because this is the one thing I needed to add, okay? If I give you this polynomial, it'll be x squared minus 3x plus 4 plus 5x squared plus 7x minus 3. Okay, so this is a polynomial, and I need to simplify it. Simplifying it means combine like terms. When we're dealing with polynomials, that's all we can really do. We're not, because there's addition or subtraction, we're not changing the exponents here. That's only when you multiply or divide. So we're just going to combine like terms. And I use an underlining method, and I'm going to use a different color grid so you can see this a little bit better. I underline using the exponents. So if there's a 2 here, I put 2 lines underneath. So anything that has a square, I put 2 lines. And anything that has a 1, I put 1 line. And anything that's a constant, I circle. Now that's my preference of doing this. So now I know when I go to simplify this, 2 lines can be combined with 2 lines, 1 line can be combined with 1 line, and then my circles can be combined. Some of you got to one of the problems, one of those division problems, it was 18 and 27, I think, and you just added them. You can't do that. Okay, they're not like terms. For you to be able to do that, they have to have the same variable and exact same exponent. So here, I've got x squared plus 5x squared. So if you have 1 pencil and I give you 5 more pencils, you have 6 pencils. So x squared plus 5x squared is 6x squared. Negative 3x plus 7x is 4x, positive 4x. And then 4 minus 3 is positive 1. And that's your answer. That's all you can do here. This, by the way, is called standard form. Standard form is when the exponents go from high to low. From high to low. And that's the way your answers have to be written. Okay, they have to be in standard form. So that's what it means to simplify a polynomial when there's addition. Now I'm going to show you one that's subtraction. I'm going to squeeze it in right here because those are a little bit trickier. So we'll do x squared minus 5x plus 2. And I'm going to put that in parentheses. Then I'm going to put my subtraction sign right there. And then I'm going to do 3x squared plus x minus 1. Now, this is where students get confused on this one because of this minus sign right here. This minus sign means add the opposite. Okay, just so you know, that's what it means. That subtraction means add the opposite. So to add the opposite, that means I'm going to change this sign to addition. So if everybody looks, because I don't want people getting screwed up on this later. So I'm going to change this sign to addition, and I'm going to change these signs to their opposites. So that becomes negative 3x squared. This becomes negative 1x, and this becomes plus 1. You change the signs in the parentheses that are right behind that subtraction symbol. And now we just combine like terms. So x squared minus 3x squared is negative 2x squared. Negative 5x minus 1x is negative 6x. And 2 plus 1 is positive 3. So this becomes your final answer. When it's addition, you don't have to worry about it. You're just combining like terms. When it's subtraction, you have to change the subtraction sign to addition, and then all the signs in the parentheses closest to that to their opposites. Any questions on that? Dylan, let's put that phone away, please, because this is new material. All right. And then the last thing I want to go over before I practice a few problems with you is what's called the degree of the polynomial. Okay. Polynomials are written with terms. Okay. They're written. Let me get one that's a little bit challenging here. No, this will work. So I've got this polynomial that has two terms. Okay. Even though there's two exponents here, this is still just one term. That's one monomial. And this is one monomial. To find the degree of the entire polynomial, you take the highest exponent from a monomial. So you might look at this and think, well, that x to the fifth is the highest. Okay, well, this is one monomial, and this is the second one. This is 4 plus 3, which is 7. This one is 5. So the highest exponent for the degree of this polynomial is here. It's 7. It's 7. So if I said, what is the degree? You'd say the degree is 7. And the leading coefficient, okay, this is where it gets tricky because there's a 5 here. The leading coefficient is the coefficient with the highest degree. The highest degree is 7. The lead coefficient here is 1/4. Let's get another one. They're not all going to be like that, and I wouldn't do that to you anyway. I like to keep it a little bit more simple. So if I gave you this one, okay, something like this one. 2, 1, 5. And I said, okay, what is the degree of this polynomial? Look for the highest exponent, or the product of the highest exponents. It would be 7. So the degree of this one is 7. So your lead coefficient should be 1. And they want you to understand that and be able to do that just so you understand polynomials and the way they're written, standard form. Bless you. I'm going to be honest with you. I'm more than likely not going to test you on that, ever. I try to limit my test and quizzes to 10 questions, 15 questions, and I don't want to waste questions on something like that. Okay. So let's do a couple practice problems, a couple of where we're simplifying, just to help you understand. I've got 6 laid out here. I'll get through what I can or help you with just a couple, and then I'll get you started on this homework so we can make sure we understand the skill before I get back into division. Okay. So when I look at problem number 1, you've got a fraction. And my recommendation, okay, and if you can't read that, it's 2x squared y to the fourth times 4x squared y to the fourth times 3x all over 3x to the negative third y squared. Now, it's my recommendation that you deal with your numerator first and then your denominator. Okay, this isn't, I mean, it is a division problem, but this is multiplication. So we need to go ahead and multiply that numerator first. So what I do, I'm going to multiply those coefficients. 2 times 4 is 8. 8 times 3 is 24. And now you add the exponents for the like basis because we're multiplying powers with the same base. You still probably can't see it, can you? Kind of small. Okay, well, you've got it in your note because I made sure it was there. So the numerator, when you take the 2 times 4 times 3 is 24. Now let's add the exponents. I've got an x squared, and an x to the first. 2 plus 2 plus 1 is 5, so that gives me x to the fifth. Then y to the fourth times y to the fourth is y to the eighth, and that's my numerator. And I'm going to put that all over my denominator, so 3 x to the negative third y squared. From here, divide your coefficients and subtract the exponents. So 24 divided by 3 is 8. 5 minus negative 3, that's a double negative. 5 minus negative 3 is the same as 5 plus 3, so that's going to give me x to the 8th, y to the 6th. And that's my final answer for that one. Does everybody understand that? Okay, so then looking at problem number 2, again, you multiply your coefficients. 2 times 3, y to the third times y to the third is y to the 6th. And then I have nothing to multiply this with, so I just write it off to the side. Just write it next to the y as x. There's nothing to multiply that with right now. And that's going to be over 3 y to the fourth x squared. I changed the order they were written so they'd match up. Divide your coefficients, subtract your exponents. So I get 2 y squared over, because this is 1 minus 2, which gives me negative 1. 1 minus 2 is negative 1. I need to move that to the denominator. So x to the first in my denominator. I put these bottom two specifically here. If you look at my scribbles for 5 and 6, because I want to be clear we understand this. A to the negative third, b to the negative third, raised to the 0 power is 1. And on this problem, okay, this term here is gone. It's just a 1. So x to the fourth times x to the third times 1 is just itself. So I wanted to take today to review the properties of the exponents and kind of show you some of this simplification and how I would attack that. Does anybody have any questions? Anything that I can further clear up? And I'm not talking about the division, because trust me, I'm going to get to that. Okay, does anybody online have any questions?
You said that you changed the order of those like exponents and variables and stuff. Can you do that with any of those problems?
Yes, you can.
Okay.
All right. Guys, if you don't have questions, I'm going to go ahead and pass out this homework that I have written. Now, you're only going to do one side of the page because when I copied it, I accidentally copied both sides, but it's the exact same assignment front and back. So just pick a side and do it. I'll be reading these answers off tomorrow in class. so you can check to see how you did if you're not here. If you are here, then we'll miss the class tomorrow. Again, it's just one side, just by accident copied it. Yep. If you have questions, please ask.
Which side are we supposed to do?
You like,
Which side are we
either
supposed
they're the same. I accidentally copied it twice. So just pick a side. For those of you online, the homework is on Canvas, so you can go to Canvas and access that. If you have questions, I'm available, but let's go ahead and get started on the homework. And I will share this video to our page.